Okay, in this example we'll look at how we can use the cumulative Poisson tables to solve some problems. And we'll start with a pretty easy one. So we've got x varies as a Poisson distribution with a mean of 2, or if you like a parameter of 2. And we want to work out the probability that x is less than or equal to 4. And to do that we can pretty much go straight to the table and look that up. So remember, we're looking for lambda equals 2 and x less than or equal to 4. Okay, so there's the Poisson table, and we're looking for lambda is 2, x less than or equal to 4, so there's our answer, 0.9473. Dead easy. Okay, let's keep going. Probability that x equals to 3. Now we can use the same trick that we used for binomial distributions to solve this one, and it's this little trick here, that probability of x equal to 3 is the same as probability of x less than or equal to 3 minus the probability that x is less than or equal to 2. And again, it's just a case of looking for those values in the table now. So remember, lambda is 2, x less than or equal to 3, x less than or equal to 2. Okay, so it's 0.8571 minus 0.6767. Okay, there we go. 0.8571 minus 0.6767, and that, when you work it out, comes to be 0.1804. Okay, moving on. I think from binomial distribution what we figured out is that wherever possible we want to rephrase these problems so that they're x less than or equal to a number, and we'll have to think about how we can rephrase this one. The first thing to notice is that probability of x greater than 2 is the same thing as the probability of x being greater than or equal to 3. Remember, because x is a discrete distribution. So if we work that out then, well, it's a greater than problem, so we'll rephrase it. We'll say that's 1 minus the probability of x less than or equal to, now hang on, we want anything that's going to be less than 3, so less than or equal to 2. Okay, and again we can just look that up in the table. Now this will come straight from the table. In fact, we've got it already over here, haven't we? 0.6767. So 1 minus 0.6767, and we can use the 9's complement to help us work that out in our heads rather than reaching for a calculator. Just remember, all we're looking for is what numbers do we have to add to 6 to make up to 9. So that's a 3. Add 2 to make it up to 9. Add 3 to make it up to 9, and for the last digit make it up to 10. So that's 0.3233. Okay, and the last problem here then. Again, we're just going to interpret this slightly differently. We've got to think, which values does this mean? And what we're really after here are the values of x equals 3, 4, 5, 6, but not 7, not including 7. So we just need to rephrase this so we can get the data from the tables. So this is going to be the probability that x is less than or equal to 6 minus the probability that x is less than or equal to 2. We can get those values straight from the table. I won't show you how to do that, I'm sure you can figure that out. So that's going to be 0.9955 minus 0.6767, and that comes to 0.3188. There you go.